Okay guys, so this is the worksheet that you had due today. I'm not gonna lie, it's a little bit of a tough worksheet. I do want to just kind of spend this video going over the answers, and you will be having a quiz on this coming up on these establishing identities. So let's kind of go over it together. I will check on this work tomorrow and make sure that you did all of this worksheet. So starting the first one. As I reminded you guys, if you have something like this and you have the conjugate of it on the other side, that is your red flag to multiply the left side by the conjugate over the conjugate. So we're going to do that. So here's the left side, which I told you only deal with the left side. Okay, and we're going to now multiply that left side by the conjugate, which is 1 plus cosine x, over the conjugate, which is 1 plus cosine x. And again, you're only really multiplying by 1, so you're not changing the value. All right, when you multiply the top, it's going to be like saying a plus b times a minus b, which equals the first term squared minus the second term squared. So it's going to be 1 squared minus cosine squared. The bottom is just going to be the sine x times 1 plus cosine x. So don't distribute it, just leave it like that for now. Okay, when we do this out, we're going to get 1 minus cosine squared x all over the sine x times 1 plus cosine x. And I'm going to remind you again of the Pythagorean identity, which is the sine squared of x plus the cosine squared of x is equal to 1. And if I were to get the sine squared by itself, I would subtract cosine squared x. And so to remind you that sine squared x is equal to 1 minus cosine squared x. I'm going to take that right here and substitute in sine squared x for that. Okay, so when I do that, I'm going to get equals sine squared x on the top. Oh, and over sine x, I'm just rewriting this part down here, times 1 plus cosine x. And then the last step is that I can cross out this sine x down here and cross out one of the sine x's up here, so that what I'm left with is the sine x over 1 plus cosine x. Okay, and just to remind you, that is exactly what it was you were trying to get at. Okay, number 2. So again, I only want you to work with the left side. So reminding you of this is that cotan I can change into something else. So let's keep this as cosine squared x on the top. The cotan is the cosine over the sine. So I'm going to make this the cosine x over the sine x. Okay? And then from there I can keep, change, and flip the bottom. This is the denominator that's a divided by, and I'm going to turn it into a multiply, and then the bottom I'm going to flip. I'm going to multiply by the reciprocal. So I'm keeping cosine squared x, changing to multiply, and flipping, multiplying by sine x over cosine x. Okay? If it helps you to put this over a 1, then go for it. I can cross cancel. I can cross out that cosine x and cross out one of the cosine x's up here, so that when I finish, I am left with cosine x, sine x, and look what I'm trying to get at. I'm trying to get at that, so I could also say that that equals sine x, cosine x. It doesn't matter, a times b is the same as b times a. Okay, so I want you to end up with the final answer being exactly the same as on the right side. Okay, number 3. Okay, again, I'm going to try to turn the sine into something other than, or tangent into sine over cosine. So here's what I got. Sine theta plus sine theta over cosine theta times sine theta. Okay, and when I do this out, this is going to be an interesting one. I am going to get sine theta, okay, plus this together is going to be, if I multiply this times this, it's going to be sine squared theta over cosine theta. Now, I'm going to remind you that when you are adding fractions, you need to have a common denominator. So if I put this sine over a 1 like that, I need a common denominator. My common denominator is going to be cosine theta, okay? So over here, I'm going to write cosine theta and cosine theta. All right, I didn't multiply this, I only multiplied this by 1, so I don't have to change this one. It's sine squared theta still. However, see this one here? I had to multiply it by cosine theta, so I'm going to multiply this top by cosine theta. So now I've got sine theta, cosine theta, and now I just simply add these together, and I get sine theta, cosine theta, plus sine squared theta, that's the numerator, and then the denominator is just cosine theta. And there it is. That's exactly what I have on the right side of this identity. Okay, number 4. I am going to turn tangent squared into sine squared over cosine squared, so let's try that. So it's going to be 1 minus cosine squared theta times sine squared theta over cosine squared theta. Okay? All right, now when I simplify this, again, if you want to, if it helps you to put this over 1, I'm going to get 1, I just have to rewrite that 1 there, minus, now when I multiply this here, this cosine squared and this cosine squared are going to cancel when I cross cancel, and I'm going to be left with sine squared theta. And you should be remembering from our trig identity of sine squared theta plus cosine squared theta is equal to 1, that when I isolate the cosine squared, in other words, I subtract sine squared from both sides, I get this, okay? I get that the cosine squared of theta is equal to 1 minus sine squared, which is what I have right here. So I could substitute in here cosine squared theta for that, and that is exactly what I am trying to get in number 4. Okay, number 5. I'm going to turn that secant into 1 over cosine x. I'm going to turn that cotan into cosine over sine x. Plus, I'm going to turn that tangent into sine over cosine x. Now, this one is a challenging one, I'm telling you right now. Okay. All right. This is the last one, so hang in there. This might be a great bonus question on a test. From here, I'm going to rewrite the numerator, 1 over cosine x. The denominator, I need a common denominator. Well, what is my common denominator down there? I'm telling you, it would be like adding 1 over 7 plus 1 over 3. My common denominator is 21, so I'd have to, because I can only multiply them together. So in this case here, my common denominator is sine x, cosine x, because I need a common denominator to add these two up. Okay, so now take a look at this. What did I have to multiply sine x to get sine x cosine x? I multiplied by cosine x. So I have to multiply my numerator times cosine x, and I would get cosine squared x. What did I multiply cosine x to get cosine sine x cosine x? I had to multiply by sine x. So what do I have to multiply the numerator by? Sine x. So my new numerator up here is sine squared x. All right, keep going. 1 over cosine x is still in the numerator. And now I've got cosine squared x plus sine squared x all over sine x cosine x. Now, you should be hopefully noticing that sine squared x plus cosine squared x, I'll scroll back, is equal to 1. That's my trig identity. So I'm going to substitute a 1 there. So that what I have here is 1 over cosine x, I'm just rewriting that, over 1 over sine x cosine x. I just substituted this 1 for right there, okay? Now you're going to keep, change to multiply, and flip. Let's see what happens. So we're keeping 1 over cosine x, multiplying, and we're going to multiply by sine x cosine x, all over 1, and now we can cross cancel this cosine x and this cosine x, so that what I end up getting is just 1 times sine x over 1, which is sine x, and this is what I was going for. All right, so tomorrow, guys, I'm going to be looking for this to make sure that you made your corrections on this worksheet, and also make sure you check Schoology for any additional homework that I gave you. All right, we'll see you tomorrow. Bye.